Uh, Hello everyone. In this short talk, I would like to talk about indeterminate forms, especially 1 raised to power infinity. So this is one of the indeterminate forms, and we want to see why it is indeterminate form. So let's consider this limit. Limit x tends to infinity, f of x raised to power g of x, where I know that limit x tends to infinity, f of x is 1, and limit x tends to infinity, g of x is infinity. So basically we are getting the 1 raised to power infinity, and that is an indeterminate form. Why it is an indeterminate form? The underlying fact is this property of around 1. So if I take 1 and raised to power any number n, it is always equals to 1. This is true for all n. If I take a number greater than 1, slightly greater than 1, and raised to power n, this will be a very big number. This will be a very big number for very large n. Similarly, if I take a number slightly smaller than 1, then this will be a very small number for large n. This is the underlying fact that makes 1 raised to power infinity an indeterminate form. So the point is how fast fx is approaching 1 compared to g of x. That will determine what will happen to this limit, right? So that's why 1 raised to power infinity is an indeterminate form. We will try to understand this by a means of example. So let's take first example. Limit x tends to infinity, 1 plus 1 over x raised to power x. Here clearly fx is 1 plus 1 over x, which is going to 1 as x tends to infinity, and here the gx is x, which is going to infinity, right? So fx is 1 plus 1 over x and g of x is over x. Now if we want to determine this limit, how we will do it is, so I'm not teaching you here to how to solve the limits. I will just want to see what is happening here. So first of all, fx is approaching 1 from the right hand side. That means this quantity is always greater than 1. So it cannot go to this limit cannot go below 1 for sure. So either its value will always be between 1 to infinity. So we'll see what happens to this limit. To solve this limit, generally what happens, consider y as 1 plus 1 over x raised to power x, take log both sides. So this is x log 1 plus 1 over x, and now take the limits both sides. Now generally when you have to solve this limit, you take L'Hospital's rule, and by using L'Hospital rules, I mean you just differentiate. So first write it as like limit x tends to infinity log 1 plus 1 over x divided by 1 over x, and now this is something called 0 by 0 form. So you can use L'Hospital's rule to obtain that this will be equals to 1 upon 1 plus 1 over x times minus 1 over x square divided by minus 1 over x square. Just I have differentiated the numerator and denominator separately. This will cancel out, and therefore you get when x tends to infinity, this is 1. Now since log is an increasing function, y should approach to e as x tends to infinity. So we get limit x tends to infinity, y is e. So we see that in this case we get the answer e. Why I choose this example? I want to play that how can I, so what is happening here? Here one is here fx is approaching 1 in the same way as gx is approaching to infinity, so that I am getting a constant value. Now let's do this example for example this one, 1 plus 1 over x square root of x raised to power x. So what is happening here? Here fx is approaching to 1 is slowly as compared to gx, and therefore therefore the answer should be very large intuitively. If I solve it this limit using the similar methods, I will get limit x tends to infinity log y is equals to limit x tends to infinity, and again we will use some L'Hospital's rule and all to obtain. So this will be equals to 3 by 2 1 plus 1 over x, and this gives you infinity, and therefore limit x tends to infinity y should be infinity. So as I said that since fx is approaching to 1 very slowly as compared to gx, it is something like 1 plus epsilon raised to power n, where n is very very large, and therefore this limit blow up to infinity. Similar, I can play around with one more example to conclude this talk. So let's take now 1 plus 1 upon x square raised to power x. So here fx is approaching to 1 very very fast as compared to gx, so at least I should get the limit near to 1, less than e for sure and near to 1. That's the idea. So let's see what happens here. Again using the similar method, limit x tends to infinity log y must be equals to limit x tends to infinity, and I will get something like this, 2 by x 1 plus 1 over x square. Using again L'Hospital's rule, I will get this, and this I get 0. Log y is 0 at when y is 1, therefore limit x tends to infinity y is 1. So it is approaching 1. So that's why 1 raised to power infinity is an indeterminate form. What I have not considered in this talk, the number less than 1 approaching to 1. So here in all three examples what I have done is taken all the numbers greater than 1 which are approaching to 1. So fx in this in all of these examples fx is greater than equal to 1. We can do similarly for f of x less than equals to 1. So by this means of example we learned why 1 raised to power infinity is an indeterminate form. For now, that's all I have to talk about. Thank you.